Assalamu students. Okay, now we talk about central finite differences. The details are for central finite differences. Okay. Okay. In abbreviation, this is written as CFD. Okay. So over here, the zeroth CFD is written as delta zero. So symbol for CFD is small delta. So delta zero f of xi that will produce the result like this. Means delta zero f of xi is equal to f of xi. Now just like that. Now as in case of FD and BFD, first CFD that is written as delta 1 f of what do you say xi, and that is written as means change the value of xi with certain amount in the forward direction. Okay, delta x by 2, let's say, and minus the value of the function at xi minus delta x by 2. So this is what is said first level CFD, and just like that, now we can define the second CFD. Second CFD is written as delta 2 f of xi, that is written like this. Delta 1 of f of xi. Okay, so this will be delta 1, and inside this result can be written for the first level what do you say CFD. This is f of xi plus delta x by 2 and minus f of xi minus delta x by 2. Okay. Okay, now so this outer delta 1 will operate upon inside. This will be what you say delta 1 f of xi plus delta x by 2 minus delta 1 f of xi minus delta x by 2. Okay, now these deltas will operate upon these function values. So according to according to the definition of central finite difference. Okay, so the result will be f of xi plus delta x, means we will increase this value of x from xi plus delta x by 2. We will add delta x by 2, so we will be getting here f of xi plus delta x minus, we will subtract delta x by 2, so this will cancel with that value, so we will getting here f of xi and minus bracket. What you say over here, we will do the same thing. We will add delta x by 2, so minus delta x by 2 plus delta x by 2, they will cancel out. So over here we will be getting here f of xi and minus we will what do you say subtract delta x by 2 from here, so this will be minus delta x by 2 minus delta x by 2, so this will be minus delta x. Okay, so opening the bracket will give us f of xi plus delta x minus f of xi. Okay, minus f of xi and plus f of xi minus delta x. And so in terms of the symbol y, we can write it yi plus 1 minus 2 yi plus yi minus 1. So this is the result of what you say second CFD. And just like this, we can write down the values of higher level CFDs. Okay, so generally, what do you say? Generally, we can write as what do you say delta n yi, that can be written as delta n minus 1, and over here we will be having delta 1 yi. Okay, so this will be delta n minus 1. Inside will be what do you say yi plus 1 by 2. Okay, and minus yi minus 1 by 2. And this delta n minus 1 will operate separately upon yi plus 1 by 2 minus this will also operate upon yi minus 1 over 2. Okay, so this is a general what you say general level what you say nth level CFT. Okay, now just like in case of FD and in case of BFD, we obtained what do you say, the finite difference tables. Just like that, for CFD we can also obtain what do you say, table of central finite differences and that table can be used during the process of what do you say, numerical calculations, like let's say numerical differentiation and numerical integration. So we will write down here what do you say, table of CFDs. Okay, so look at the table of CFD or CFD table. So again, we will be having a certain given data. Okay, now this is xi and these are yi, which can be written as delta 0 yi. Okay, zeroth level CFDs, and the values are x0, x1, x2, x3, and x4, and the corresponding values of y are y0, y1, y2, y3, and y4. So these values of y themselves are zeroth CFDs at these values. Look at this is delta 0 y0, and this is delta 0 y1, this is delta 0 y2, and this is delta 0 y3, and this is delta 0 y4. Now we come to the first level, what is the CFD, and which is equivalently written as delta 1 f of xi. Okay, so the values of first level CFDs will be written in between, uh, in front of what do you say, the middle area of the values of values in the previous column. So over here we will be writing here delta 1 y0. Okay, and this will be written as actually delta 1 y1 by 2. Okay, 1 plus 0 divided by 2. So over here the suffix or the index value will be written as 1 plus 0 divided by 2, the average of these index values, so 0 and 1. So 0 plus 1 divided by 2, so over here 1 by 2. So and the result will be y1 minus y0, means the value, the result of delta 1 y1 over 2 will be y1 minus y0, because when we will increase the value of x by delta x by 2, so this 1 over 2 plus 1 over 2, this will give us 1, and when we subtract 1 over 2 minus 1 over 2, that will give us 0. So over here we will write here delta 1 y, what do you say, 3 by 2, this will be y2 minus y1. Over here this will be delta 1 5 by 2, and this will be y3 minus y2, and over here this will be delta y 7 by 2. Okay, and this will be what you say, y4 minus y3. So over here the suffix values are obtained from here, from the previous column. Look at if you are writing the result in front of the middle of these two values in the second column, in the first level CFD column. Over here 1 plus 0 divided by 2, this is 1 over 2, so, and the answer will be y1 minus y0. So over here 1 plus 2 divided by 2, that is 3 by 2, so and the result will be y2 minus y1, and so on. Okay, so for the second level CFD, delta 2 yi, again you will write the result in front of the middle area of the values in the previous column. So over here again we will take 1 over 2 plus 3 over 2, that is 4 over 2, and 4 over 2 divided by 2, that is 2, what is 1. Okay, so over here we will writing here delta 2, what do you say, y1, that is equal to delta 1 y3 by 2 minus delta 1 y1 by 2. Okay, so look at over here the index value is coming from where, that is 3 over 2 plus 1 over 2, that is 4 by 2, and 4 by 2 is actually 2, and when we will divide 2 with 2 we will getting here 1. Over here we will add 5 by 2 and 3 by 2, that is 8 by 2, and 8 by 2 is 4. 4. You will divide 4 with 2 further, and you will get the suffix value to be 2. So this is what you say, delta 2 y2, and this will be the difference of first level CFDs. Okay, so this value is actually in between these ones, and in between these two values over here, delta 2, what do you say, y, over here 7 over 2 plus 5 over 2, that is 12 by 2, that is a 6, and you will divide 6 further with 2, that is 3 here. So this is 3, and you will get here delta 1 y 7 by 2 and minus delta 1 y 5 by 2. Okay, and in the next one, that is the third level CFD. Over here again we will what do you say, add 1 and 2 and divide by 2, and that will be delta 3 y 3 by 2, and that will be equal to delta 2 y2 minus delta 1 by 1. And over here we will writing here delta 3 y 5 by 2, and that is equal to what you say, delta 2 y3 minus delta 2 y3 minus delta 2 y2. And the last one is the fourth CFD. There are only two values left in the previous column, so that's why over here we can write only, we obtain only one entry in this column. That is what is say delta 4. We will take, let's say, the average of these values, 3 over 2 plus 5 over 2 and divide by 2. 3 over 2 plus 5 over 2, that is 8 by 2. 8 by 2 divided by 2 is what is 2. Okay, this is delta 4 y2, and this will be delta 3 by 5 by 2 and minus delta 3 by 3 by 2. So this is what you say, the last column possible in this table. Okay, so this is the table of what you say central finite differences, and the specialty in this table is that the odd level, what you say, CFD column is involving the fractional suffix values are the index values over here, and the even level, what do you say, uh, CFD CFDs are involving uh, the suffix values to be integral values, positive integral values. Okay, so look, you can look at over here again delta 3 yi, it is involving the fractional index values over here, and the fourth level is again involving here the suffix value to be 2, means the index value is 2 here. Okay, so this is what do you say, the CFD table, central finite difference table. And again, the advantage of this kind of table is very, what do you say, is uh, the use of this table uh, during the process of, let's say, numerical integration and numerical differentiation. Thank you.